So here, basically, you're given some information, and what you're trying to find out is find the number of elements in A. So basically, the best way to do this is graphically drawing it out, but otherwise you don't have to do that. But I will just do that for the sake of explaining it. So in case you don't know what these symbols mean, this denotes a set, and in this case it's talking about the union and intersections of different sets. So we can look at these elements in a Venn diagram, because since we're dealing with three, we can have three circles. And yeah, right there. So when it says that we have, okay, let me just label this A, B, and C. So basically it says that set A has 16, so that's the entire circle, that's the entire set, including these intersections. So to start off, let's go outside in to find out what's in intersections, so we can decipher what are in the other areas. So here, in case you don't know, this means intersection. So it's saying the intersection of A, B, and C is equal to 3. So we know that for sure, since that is the smallest area and that doesn't overlap with anything else internally. And then if you look at that one, let's look at the other intersections before going back to A. So you can see that the intersection of A and C is equal to 4. So you see here. But this intersection includes the intersection of all three circles. So that means the total must be 4. So that means this must be 1. Now we see the intersection of A and B, and you see the same thing, 7. So that means these two must add up to 7. So that means this is 4. And since we knew that the set of A had 16 total, we know that the elements of A only would be, sorry, the question was the elements of A only. So yeah, so you would subtract what's 1 plus 3 plus 4, which is 8, and you get 8. Now for the second question, basically it's asking for us to see so the question says, how many of the fractions in this set have non-trivial repeating decimal expansion? And where it says a repeating expansion where the repeating part consists of zeros or nines is considered trivial, like in the fraction 1/2, where the decimal expression is 0.50000 repeating, etc. So as we know, this is dealing with denominators and how they're ending. So let me just write out all the numbers themselves. And basically, this is a counting problem like you see in other math competitions. However, this is coming up early, so you have to make sure you don't spend too much time contemplating over what the answer might be. So we're trying to find the non-trivial repeating decimal expansions. So that means we need to cross out all the ones that are considered trivial. So which ones are considered trivial? So let's look at the numbers and denominators. So we know 2, 5. Let's write out some of the numbers we know. So 0.5, 0.3 repeating. So that's not going to be it. That is a non-trivial number. But you see that any multiple of 2, this is going to be this divided by half. So it'll not have a repeating number. So that means it will have to be trivial. So from that we can eliminate 2, since it's going to be trivial, 4, 8, and 16, because they're all trivial. And we know that because you're going to keep on dividing 0.5 by 2 by 2 by 2, and it's always going to have that repeating 0 pattern, like you see, because 0.5, 0, 0, etc., right? It's same thing as they're just 0.5. And then from that, now we have a few down. But one other thing is that 10. So this is represented as 0.1, and this is represented as 0.05. So we can cross those two out too. So now we are left with 1, 2, 3, 4, 5, 6. There's a total of 19 numbers, so we eliminate 6. There's 13 left. But let's look over these numbers a couple more times to make sure we haven't missed anything. And take this time and try the problem before I do it, just so you know your thinking process and you can identify where you got stuck. So in general, before I start the problem, take some time and try it yourself. So, yeah, though I already went ahead in this problem, we know that 5 is 0.2. So that means that's also trivial. And that was just looking at it, you don't want to spend too much time on it. So you know this has a multiple of 3, which is 0.3 repeating. So that means that we'll have to repeat. 6 is multiplied by, is this divided by 2, right? 1/3 to 1/6 is 1/3 divided by 2 is 1/6. So that means that's also going to be repeating. 7 is prime number. 9, you're going to have, again, it's related 3. 11 is prime. 12 is related 3, prime. This is related 7, which is also prime. So, and then you can eliminate 18 too, because that has 3 in it. And then 17 is also prime. And 19 is also prime. And since we are not given a calculator, you can't trial and error. So, and in general, it's good for you not to trial and error. Now it's problem 3. Basically, this is another counting problem, and there's a property that states that for a triangle to be a triangle, the smaller two sides must be, I'll denote this by x and y, the sum of the smaller two sides must be greater than the greatest side. So we can apply this here, where we are given a triangle, with the lengths A5 and B, and we're trying to find out how many ordered pairs A and B are there. So let's go to the counting process. So to start off, you know that the minimum of this, it has to be an integer also. So keep that in mind, it has to be a positive integer. And so obviously A can't be 0. So we'll start at 1. So A is 1. Then for it to be greater than 5, we can do 1 and 5. And soon enough, you'll see that if you have A as 2 now, you're going to be able to do, you're going to have the sum of 7. So basically, you're going to have this becoming 6, because this is always the greatest integer. So this is always going to be small. So you're going to have, instead of here, you're going to have A plus 5 is greater than B. And you're just going to use this to count up real quickly. And you can see that when B is 5, which is the minimum value, A has to be 1, since it's lower. But A can be 1, it can be 2, it can be 3, it can be 4, it can be 5, until it reaches maximum, because the smallest two must always be greater than the sum of the smallest two must always be greater than the biggest. So from that you get 5. You have A is 1, A is 2, A is 3, A is 4, A is 5. You can also graph this out. Then you have when B is 2. If B is 2, then you have when B is 6, since that's an x number up. Then you see that this has to be bigger than that. And since the cap is of this is 5, you have 1 less. And if you keep on going, you notice this pattern that goes 3, 2, 1 after you're done doing that. And then you can sum it all up. And the sum of this is 15, and that's what the answer is. In problem 4. So here we're given a transparent a 4 by 4 by 4 with 64 cubes. So there are 64 cubes, we're given that. And this problem is basically asking if I were to paint a 4 by 4 by 4 cube, and while the picture consists of small unit cubes, smaller unit cubes, how, if I paint all the sides, what is the probability a cube will have red paint on only 2 sides? So this problem, we can see that we're looking at, those are these middle edge areas. So we have 1, 2, 3, 4. So this is another counting problem. So basically, you know, you're looking for these edge areas, and you're gonna see that there's 2, 4, 6, 8. So there's 8 on this side. Then you're gonna have to count the ones on the complete opposite side, which gives you another 8. And then also the ones in the middle. And you have this, you have 1, 2, 3, 4. So that means you're gonna have 4 times 2, which is another 8. So hence you have 24 cubes out of this total 64. And what that reduces to is 16 over 6. And eventually 3 over 8, which is the answer. Now for number 5, it's giving you a sequence of numbers which goes on, and then you're gonna have, it's telling you that, and then you're gonna have this going on and on until infinity for n value of 1, 2, all the way to infinity. So basically, this is the equation you get, and what it's telling you is that a of 2019 is equal to 2019. Find the value of a of 2018. So when attempting these problems, you always want to try to find some pattern, and often they give it to you. So let's just try listing out some of these values and try to get some type of value for it. So ace of 2020 would be equal to ace of 1 all the way to 2019 ace of 2019. So 2019 ace 2019 times 2000 ace of 2019. And the same thing applies here. So let's write it out real quick. So this is one thing you should, this is one thing you should pay attention to, is that to always look by the numbers they give you. So if it's gonna be ace of 2018 we're looking for, you would do the first couple numbers around it, since you're trying to find its value, because you might be able to eliminate something potentially in terms of solving for it. And then you have, so then from here you have your values. So now you're gonna be, so remember this. So now just look at what happened. Try this problem on your own now that you know this, and I'll give you a couple seconds for that. So back to the problem. Here, basically, if you just look around here, you can figure out that for 2000, you're looking for ace of 2018, and you know ace of 2019, so that's given. But let's see if we can eliminate something to be able to solve for ace of 2018, potentially. So we know, let me just try a couple things. So if I were to subtract ace of 19 from ace of 2018, sorry, forgot to denote that, is 2019 minus ace of 2018, what would that equal? That would equal to 2018 ace of 2018. Now, remember, we're using this because we already know this value, and we know this value, so let's substitute it for 2019, and look what we just have here. We have an equation with only one variable. So now we can solve And we see that 2019 equals 2019 times ACE of 2018. So that means 2019 over 2019 equals ACE of 2018, or in other words, is equal to 1. So that's how you solve that problem. So now to problem 6. So here, it's asking, there's roots x1, x2, and x3 of the equation as shown, and what we're looking for is x of. So there's one key concept to be known here, and that's Vieta's formulas, and that what you always want to look over that before you do any problem involving roots, because usually there's something hidden or related to that. So since it's a cubic formula, let's just put it in solving form. Vieta's formula states that negative b over a equals the sum of the roots. So it's listed as x1 plus x2. But this isn't a quadratic equation, mind that. So, and this would be equal to, so wait, let me clarify that, and then this would be equal to x1 times x2. So what that gives us basically is that this can also be applied to our cubic equation. So the same thing applies to cubic equations. Basically the same thing applies. So we still have negative b over a equals the sum, and c over a equals every other number. So let me show you that. So instead of d over a now equals the product. So, and this would be x2 plus x2 x3 plus x1 x3, and yeah. So now you have this, and you have that negative. So this actually continues this pattern for any equation. Let's say it's a quartic equation, you would have e also, but that would be positive. You see how it's alternating? So basically, this is you can prove this formula also, but basically we can use this in this equation for this problem, I meant. So here we're trying to look for these numbers, correct? So let's see if we can apply this. And often of the time, most of the time, you are able to apply this and successfully solve your problem. So here, let's just figure out all this, right? So let me just redefine this. So in here, we have no value, so it's equals 0. Here, we're gonna have c over a, and there is no value, so we don't have anything there. And here, we have negative d, negative 1 over 1, which would just be 1. Now we know that the product of all of the values is equal to 1. What can we do from that? Well, look back here, and it says for counting numbers, but let's ignore that for the moment. And let's try to evaluate what x1 plus x2 plus x3 to the power of n, respectively, individually, are equal to. So one thing we do know is that from this equation, by solving, you know that this is equal to that, and that means 1 is one of the roots. Is the solution to 1 is one solution. So that means let's just assume one of these is a solution. So that means remaining two, let's say x1 and x2, let's say x3 is equal to 1. That means these two remaining are also, the product is equal to 1. So now what do we do with this? So now we have 1 plus x1 to the power n plus x2 to the power n. So now we have that. So you may be asking now, how does that relate to what we have? Well, if you look closely to the value to one of the solutions. One of the solutions has x. One of the solutions, D has x1n, x2n, plus x1n, x3n, plus xn, x3n 2 times. Yeah, so, but one thing we notice is this is 1. So we know that, let me write it out real quick. So one of the answers, D, says, is it equal to this? And let me write out what it says. And in this process, you would just look for anything that looks similar to this value and identifying the fact that x1, one of the values is equal to 1. So if you look at D, we see that this is the answer that they give us. And if you notice that one of the solutions is actually 1, as shown back up here, so that means that, and we marked as x of 3. So x of 3 is 1. And if we see here, that means this is 1. This is 1 also. And then we know that the product of this is also 1. So that's 1. And now look what we have here. X of 1 to the power of n plus x of 2 to the power of n plus 1. And that's exactly what is equal to this. So that means D is the answer. Here we have a geometry problem. It gives us a, I'm just going to label it real quick, a triangle and BC. So it's telling us that what is this altitude? And one quick thing we can use from our books is that we know the triangle, of the area of a triangle. What is that? AB over 2, because that is the height, since we know it's a right triangle, the height and the base over 2. But what about here? So one thing that we know is that it tells you it's an altitude from the right angle. So irrespective of whether it's a center or not, it tells you it's an altitude. That means this is 90 degrees, 100%. So let me just put this altitude as x. So that means C of x over 2 must also equal the same area. So now, let's see what we can do here since solving. So we have to solve for x, right? And since it's asking for the area in terms of the other side, so we can quickly see that AB equals C of x, and that AB over C is equal to x. And this is the altitude, so that means that's the answer. Now on to problem 8. So here we have a couple things they're asking us, and they're saying which ones are true. So the first statement is that the only negative root of p of x is equal to x of 3 minus 3x plus 1. And then saying for second one, log on base 35, 1 plus 2 plus all the way to 49. And then last one is that q of x is equal to x of to the power of 3 minus 15x minus 50. So quickly, let's start with statement 1. So statement 1, we can see that, let's use a quadratic formula since it's not factorable clearly. So that's 3 plus or minus b squared was 9 minus 4 ac, which is just 4 because there's nothing else, and then divide by 2. So this is what? 3 plus or minus root 5 over 2. And that's what the solution is. So this tells us that regardless of, we know that root 5 is slightly above 2, but not as big as 3. So that means there is no negative solution. Hence, 1 cannot be true. So we know that that's 100% wrong. For number 2, we have the sum of this. So let's find the sum of that. So there's a really nice formula out there that that can be proven that also shows you that the value of the integers 1 through n is equal to n times n plus 1 over 2. And here we can use that formula. So 49 times 50 over 2 equals 7 squared times 5 squared, which is also 49 times 50. And what we can do is we can use the property of logarithms. Here, let's see, log 35. You have 7 times 5, and we can say whole squared since they're both individually squared also. And we can use the property of logarithms and see that this is 35, and that this can be carried over to be multiplied. So we now have this, and we all know this is equal, since 35 to the power of 1 is equal to 35. So we can cross this out. So this is 2. That, and what it was saying is that which of the, and what it's asking is that which of these statements can be represented as a rational number, is a rational number. So the only negative root of this is not a rational number because, first of all, we're dealing with square roots, so it's not going to be rational, and it's also not going to be, there is no negative root, so that's definitely no. But 2 is an integer, and it is a rational number. Now let me erase all this to get some more space for the next statement. And here we have a pretty nice looking cubic equation. So here, don't get scared by the cube over the x, because it might still be factorable. We just have to look for it. So if it was factorable, you would have 1x here, and you'd have 1x squared. Before we go further, it could be a cube, but it doesn't look like it at the moment. And we can see that there's a 5 in common. And 1 has to be negative, so let's just say this is. Otherwise, we can always try it the other way around if we need to. This number, and you're trying to look for a factor, correct? So you might try, does some square work? But instead, let's try to identify anything involved with x minus 5 or anything involving with 5, since we know that's one of the common factors. So let's just set up our next bracket here. And so here now we have both of the potential factors, if they are even factorable. We don't know that yet. So here we know that this must be positive 10, because it will essentially end up being negative 50. Let me just arbitrarily name this is of x, and you're seeing that you have negative 15. So let's see what we can do here. You have negative 15. So that would have to be equal to negative 5a, or 5a in general, we don't know what it is. 5a plus, know that we know that negative 15 and negative 50. So that means the sum of the middle term must be negative 15. So from that, we can see that the middle term must be negative 15x. So whatever a is, so you have x times x squared, that gives us x cubed, that's what we want. Then you have 8x squared, which that means that will have to eventually cancel out. So that means we have an extra ax squared. Then you have 10x, okay, that's fine. Then we have negative 5x squared. So then you have negative 5x squared. So right away we know that a would have to be, if anything, 5. So let's see if that works. X minus 5 times x squared plus 5x plus 10. And we can see that that actually does work out, and we have a potential solution for this equation. And since there's only one positive root, this should be a negative sign, so that means that 5 is another positive root, so that means the only answer could be 2 and 3. 2 and 3. Now let's go into problem 9. So quickly we have this large scalar expression, but if you look at it closely, basically all it's asking is that, a bunch of comparative expressions. So I suggest you guys try this out on your own while I'm trying to write it out. So here, basically, it's saying that V says the following. And basically what we're trying to find out is what is the resulting expression. And where it says that the down signal denotes that the larger should be the one outcoming of that expression, and the up signal means that the smaller one. So basically opposite of what you would logically think. So from that we can quickly see that this must be the larger one. And we see that this one will be larger due to the expression we're given here. And hence we can get Z out of this since it's going down. Let's cross it out. Then here it's saying the opposite. So this is pointing up, so that means it's asking for the lower one. And that would be V here. So that means out of coming here is V. And now we're facing another caret symbol. So let's get the other side expression done first. So the down means it's looking for the greater. And since an X shown by the equation is greater, so we get X out of that. Then we get smaller of these two. And clearly that's W. Then down here we have Z and Y. The smaller of them is Y. And then here, the greater of these two is Y. And that means guaranteed Y will be coming out of this bracket. So we get Y. And now let me just simplify it out. You have V with the caret symbol. I'm just gonna mark it like that. And then Y with the V with Y. So here it's looking for the larger value, which is W, and then here it's looking for the smaller value, and that's W. So that means the final answer is W. It's more of a logical problem than most, and is simpler as a result. So here, basically, we're looking at a type of sequence and saying you have two moves. You have to get to 10 feet, and essentially after reading all the stuff they tell you, you can basically eliminate everything that's irrelevant, and just all it's asking you really is you have a 1 foot step and a 2 foot step. How many ways can you get to the 10-foot mark? And it's a lot simpler than you may think. Here, you can just go ahead and let's just compute some values of this to see if we can find any patterns in the addition of the moves. So let's say if you have 1 step, obviously you can do 1. Here you can do 2 only. And R of 3, let's just see if we can find any patterns. And this is denoted by how many steps you can have. So R of n would have n steps. So if you have 3, now this might get a bit complicated. You have 1, 2, 3, then you have 2, 1, 1, 2, and then you have, that's it, it's 3. And you see this because previously you had 2, right? And you could replace it with a 2-step or 2 1-steps. But after you add 1 more, you add, and then in the previous step you only had 1. But after you added 1, you now suddenly have this extra 1 additional component that you can replace it with. So essentially, let's try this for 1 more value and see if we can see this pattern continues. You see it's adding up like the Fibonacci sequence. See if it continues. And R of 4, basically, you're gonna have 1, 2, 3, 4. You have 2, 2, 2, 1, 1, 1, 1, 2, 2, 1, 1, 2. And then you're gonna have 1, 2, 1, 1. Sorry, I think I had an extra one there. And then that's 6. And I think, yeah, so that's the maximum amount. And you can see how this keeps on adding. So it's actually 6. So you can see this model is Fibonacci sequence. And if you continue this, you find that all the way to R of 10, you find that's equal to 89. And that's all for these first 10 problems. I'll be sending more videos with the future ones.